Okay, let's apply what we've learned. Here are a review of our two rules. We know that if it's outside, it's going to move up and down and be the same as what we think it should be. If it's inside, it's going to move it side to side, left and right, and it's opposite what we think it should be. Let's start by applying this. First off, these parent graphs should look familiar from 1.1. If you don't remember, you can go in and double check 1.1, but we're going to just copy them in from 1.1. So this is our parabola from 1.1, x squared. X cubed is our dead worm on the sidewalk, is my little nickname for it. And there's a couple points that are on it. And then our square root of x has these points on it. Looks like that. Now let's talk transformations. That -2 is outside our function, which means it's going to move the function up and down, and it's going to be the same as what we think it is. So negative will be down. So this means move down 2. So I look back at this graph and just take all the points and move them down 2. There we go. Do this, so that's our first example. Do this example. Now that +3, now that's on the inside. So that means we're going to move left and right and opposite what we think it should be. So that positive is going to be left 3. So once again, take all those points from the original, but now I'm moving them all. Ooh, there we go. Come back. Now I'm moving them all left 3. Should get something like that. Now negative. This negative is on the outside. So that means it's going to be a reflection up and down. So I'm going to take my original parabola, but reflect all the points downward. Like that. This one is an inside negative, so this is reflecting all the points left and right. Now on the parabola, that doesn't make a whole lot of difference because it's symmetric across that y-axis. So even when I reflect them across, they still look the same. Now let's try an example where we do several at the same time. We're going to start order of operations. So parentheses first, then multiply, then add. This +1 is on the inside, so side to side and opposite. So that means it's going to move left 1. That negative is on the outside, so it's going to reflect up and down. And then that +2 is on the outside, so it's going to be up and down and the same. So that will be up 2. Now, here's how I'm going to do this. I'm going to try and color code this for you. So, first one, I want to move everything left 1. So all those original points get moved left 1. Like that. Next, going to reflect everything up and down. So reflect, reflect. So now I've got that one. And finally, I want to move everything up 2. So that black one is my final one. And you can either make it thicker, or you can color code it, or you can erase the other two, whatever you want to do. So doing that, knowing that, This second line is all the same exact transformations, just applied to a different parent graph. So what I want you to do is pause the video, try these ones out on your own, and then come back and see if you did it right. Okay, you should have gotten something that looks like these ones. And we're going to add another step onto this too. We now want to write the equation. So this equation will be x cubed minus 2. The negative 2 is on the outside. This one I want the plus 3 on the inside. So x plus 3 cubed. This one I want the negative on the outside. This next one I want the negative on the inside. This one I want a negative on the outside, a plus 1 on the inside, and a plus 2 on the outside. So that's how we come up with the equations using this function notation for that. Okay, go ahead and try this last one on this page. Once again, pause the video, try doing the graphs and the equations, and then we'll come back and see if you did it right. Okay, there's your bottom row. You can check what you got with what I got. Pause the video if you need more time to check. In the next video, we're going to practice our dilations on the next page.